Happy Pi Day, Coding Train passengers. Welcome aboard. I've heard you in the comments. I've heard you say, oh, I miss those old simple coding challenges like the Snake Game and Purple Rain. When will you do another one of those? And I am here to tell you that today, Pi Day, I want to make a game with the digits of pi. It's going to be a basic beginner-friendly tutorial. You can make your own version of it. I hope you will make your own version. And the world will be filled of beautiful, delicious pies.
It's Pi Day. Delicious and sweet, it's the only number that you can eat. It's Pi Day. My favorite treat, circumference divided by diameter d. It's Pi Day.
Let me tell you a story. Oh, it was many years ago, in the 2000s, when I was first writing up some tutorials about processing, in HTML, and uploading them through FTP to the internet, when someone came to me and said, why don't you put these tutorials into a book? And I said, no, I couldn't possibly, I couldn't possibly, okay, if you insist. That book was called Learning Processing, and you could buy it today, but I don't suggest you do, because I don't know, maybe it's a little too out of date. But that book, at the end of chapter, 6, after all the fundamental basics of programming are covered, variables, conditionals, loops, functions, objects, arrays, and all those things were put together in a game known as the Raincatcher game. Well, I am here today to present to you the game Pie in the Sky. The idea here is that's a plate and there are pies falling from the sky. The player must move the plate to catch the pies. Aha! But there's a catch. The pies have a certain number of slices. And you, as the player, must catch pies in the correct order. You must catch a pie with 3 slices, then 1, then 4, then 1, then 5, then 9. And if you don't, you lose points. If you do, you gain points. This is the basic idea. Let's go make this game. So here we are in my happy place when I like to spend Pi Day in, the P5JS web editor. And the first thing I need to add is the plate. And the plate, I'm just going to place it where the mouse is, at the bottom of the canvas. So I would like the plate to be centered on the mouse. And there's my beautiful, beautiful plate. Change the background to 0, and we're starting the game. Next up, I want to add the falling pies. I think to do that, I'm going to want to make a pi class and an array of pi objects. So the idea of a class is a template for making an object, a thing that's going to exist in the world of my program. It has a constructor function that initializes a set of variables or properties that belong to that particular object. So I could create a variable called pi. Once I've created the pi object, maybe I want to draw it on the canvas. I can go to the pi class and add a function that draws it. Then all I need to do is call show on the pi variable. Now I have both my plate and my pie. Next, I would like the pie to fall from the sky. To do that, I'm going to increase its y value every time through draw, adding another function to the pi class called update, and increasing the value of y by 1 every time update is called. And there falls the pie. So clearly I need some mechanism by which I compare the pie's location to the plate's location when it reaches the bottom of the window. I'm kind of feeling like I want to make a plate object. So the plate needs an x position, which is variable, a width, which is how big is it, and then its height and its y position are locked to the bottom of the canvas, although that is something that potentially you could also experiment with. Now I can create my plate object. Oh no, it's happened. I can't believe it. You know what I've forgotten, right? If the variable is a property of the object in the class, we must refer to it with this dot. There we go. Oh, but I can't move the plate. So now, how do I know if the plate has caught the pie? If the plate catches the pie, console log yum. This is one of the things I love about object-oriented programming, and I should just take a minute here. If you happen to actually be watching this video and you have no idea what's going on, I'm trying to step through it slowly, but ultimately what I'm making use of is the fundamentals of programming. I've got variables, I've now got a conditional, I have objects, soon I'm gonna add an array, then I'm gonna need a loop. I'm gonna talk you through these things. Maybe you're a beginner and this is your first time coding. If so, hello and welcome. But I also want to mention that what I'm doing here is synthesizing everything that I have in my Intro to Coding with P5JS playlist. And if you want to go back and kind of learn all of these pieces more slowly and step by step, you can take a look at that playlist, which I'll link to in the video's description. But what this means here is that I need a new function inside of the plate class called catches to receive a pie and do something with it. What does it need to do? Well, if it's in a conditional statement, if the plate catches the pie, it needs to return true or false. I could just say right now, return true. So now look at this. I'm catching pies. I'm always catching pies. The pies are falling. I've got them all. I'm eating them all. It's too much pie. Help! So it would make more sense for me to first test if the pie's location is down at the bottom of the canvas where the plate is. I'm going to do this in the simplest way possible first. I'm just going to say if pie.y is greater than or equal to the plate, which is this dot y. Then I'm going to return true. Otherwise, I'm going to return false. And now I just write the code this way because I love seeing the flood of comments on my YouTube video about how I could have written this. I mean, yes, it's one line, it's kind of elegant, but let me just have my piece. All right, that pie is falling really, really slow. I caught the pie. Let's try it again. I caught the pie. So clearly I also need to check if the pie is between the boundaries of the plate. If the pie is at the bottom and pie.x is greater than the left edge of the plate, that's the plate's position minus half its width, and its right edge, which is its x position plus the width. Let's run it. Okay, I'm gonna catch the pie. Oh, what? Oh no.
This dot,
Oh no, it's happened again.
this dot's on.
I have caught the pie. Try it again. I have not caught the pie. What's next? We have variables, we have conditionals, we have functions, we have objects, but we don't have arrays or loops. Well, instead of one pie, let's make a variable called pies and set it equal to an empty array. I could say the first element of the array, index 0, is a new pie. And my code doesn't have to change other than just referencing the index 0 of the pie's array. But what if I want to have more than one pie in the array? Pie's index 1, the second element of the array, is another pie. Oh, but I only see one. This is where a loop comes in. Now I can write a loop, this is called a for loop, where I have a counter I, which goes from 0 up until the length of the array, counting through every single pie. Then instead of referencing index 0, I can reference index I. Now I have two pies, and I can test both of them, all of the pies, against the plate. Now, this is a little bit silly what I've done by just individually assigning each pie into that list, into that array. What if I want to have 100 of them? Well, I can actually use a loop as well in setup to put a whole bunch of pies in the array. Let's put 314 pies in there. And in fact, even though I can do this by referencing the index I can use a function called push to just push pies into that array without having to worry about the index. This allows me to also use a slightly fancier loop called a for of loop. Now instead of counting through the pies, I'm saying for every pie, I want to say the word in. And it's a long story why I can't say the word in, even though I could say the word in, but that's something else in JavaScript. For every pi of the array pies. Show it, update it, check if the plate catches it, and if so, console log, yum. But I still only see one pi. All the pies are being created at the same exact location. So let me give a random location. Anywhere in the width of the canvas, and actually let me set it up so that it starts above the canvas itself. So it's raining pies. So anywhere between -100 and -20, those are pixels off the canvas. Oh, look at all the delicious pie. Let's go back to 31 pies. And actually, I have a different idea. Why don't I just add a new pie every frame? So I'm actually going to start with 0 pies. But just in draw, I'm going to push one random new pie every time through draw. It's raining pies. Now we have a problem. I'm adding pies. I'm trying to catch them, but I haven't eaten any. And my animation is starting to slow down. So maybe every time a pie gets to the bottom, I should get rid of it. So I want to say something like, if pi.y is greater than the height of the canvas, eat the pie. To remove an element from the array, there's a JavaScript array function called splice. But splice requires me to reference which element, the index to the element. So I need a kind of loop where I'm counting the index values. So I'm back to referencing index I. If the pi at that index is greater than height, eat the pie, or remove index I and only that element. Now I believe that the elements of the array are being removed as they get to the bottom. I can't be sure. What if I use a console log and look at the length of the pies array? Lots of pi, lots of pi, lots of pi, lots of pi. Oh yeah, stabilizing. We are not getting more than 100 pies. I have done something in a way that's slightly problematic, however. And I've covered this extensively in my videos around objects and arrays and removing objects from arrays. But in this case, if I'm going to be taking elements out of the array, it's important that I go through the array backwards from the end to the start due to the way the array recalibrates itself when things come out of it. Now I'm realizing something here. When the plate catches the pie, I also want to take it out of the array. It's done. It's not eaten, it's caught. So I'm eating some pies, catching others. It's confusing what's going on here, but regardless, any pies that make it to the bottom, whether they're caught or go past the plate, they need to be removed from the array. So I'm going to take the if statement from the loop up top and bring it down here to this one. You're probably thinking, oh, what about consolidating these two Boolean tests? This if the plate catches the pie or if the plate goes off the bottom. And yes, I could do that. But right now, I think I want to do something different in each case, whereas this is just saying goodbye to a pie. And here, I need to remember the whole goal of the game is to catch the digits, check what digit was caught, and deal with score. But let's also clean up a couple things. One thing you might notice is as the pies get to the bottom, they kind of disappear before they're really gone. So I think in this case, it would make sense for me to say, if pies index I dot y is greater than height plus, and let me look at the pie object. Oh, I have hard-coded 32. So I have this, I'm going to use D for diameter, or let me say actually R for radius, and make it 16. And this is going to be this dot R. I remembered the this dot times 2. And then in the sketch, I can see if the pie's Y position is below the height plus the pie's R. And now it just looks a little bit more elegant as we don't see the pies disappear until they're off the bottom. But what about the pies that are caught? How about if pi.y plus pi.r? Now you can see how those pies disappear right at the plate, whereas the other ones move past below the canvas itself. I don't need this console log anymore, and also it's a lot of pies, so let me reduce the number of pies by adding some randomness. I'm only going to add pies randomly, maybe 1 out of every 10 times through draw. So now by picking a random number between 0 and 1, and only if it's less than 0.1, that will be 10% of the time, do I add a new pi to the game. Eventually, I want these falling pies to represent the digits of pi, and the player has to catch the right digits. So I want to design them with slices and all of that, but for now, let's just put a number in the center of each pie. So every time I make a pie, it'll pick a random digit between 0 and 9. And I can use the text function to draw the digit right there over the circle itself. I don't see the number. Oh my goodness. Order of operations is an important thing. I'm drawing the circle after I'm drawing the text. So I drew the text, but then I covered up with the circle. Drew the text, but then I covered up with the circle. Let's fix that. There we go. Now they're all the number 1. Now we have digits falling from the sky. Oh, what happened to my plate? I wasn't very thoughtful about making sure I set the color of everything I'm drawing. So now I have my plate back. It's still too many digits because it's going to be very hard to catch one and then move out of the way. Let's make the plate a little bit smaller, a little less frequent with the digits. I guess a little bit more. Also, I would like these digits to feel like they're falling more. Right now, they're moving at a constant speed down. So if I add an acceleration so that that speed changes over time, that's as if gravity is pulling them down and they're accelerating as they're falling. So if I were to start with a y speed of 0, if y speed increases over time, well, it probably should increase a little bit faster. Now they feel much more like they're falling. Now, I have an idea. I think what I want to be able to do is display the string of digits that I'm catching below the canvas. Even though I'm using dark mode for the web editor, I can change the background color of the canvas area to be white by altering the CSS. Then I can add a paragraph element to go below the canvas. So you can see it there as the word hello. Let's make that a little bit bigger. I'm going to call this digits div, start it as empty, and then have a variable called digits be a string itself. Every time I catch a pi, I want to add its digit to that string. But I also need to make sure the div is updated with the current value of that digit's variable. Here we go. I'm going to catch 1. Oh! Well, that's a problem. I better do that before I delete the pi from the array. Okay, here we go. No! HTML digits. Oh, it's not digits p, it's digits div. 6, 8, 9, 4, 9. That's not pi! So first of all, let's start it with 3 dot. So we'll make, the idea of the game is I need to find a 1 first. And I need to avoid everything that's not a 1. There it is, there. 1. Oh no, ah! Wait, what just happened? Oh, I can't put that there. It needs to go here. After all that. Okay, here we go. 3 point. There it is. 1. And I need a 4. Give me a 4. Wow, this is hard. Oh, there we go. 1, 4. 1. All right, so there's some playability issues here. I mean, one thing would be to make a bigger space and then have more digits falling. Is it never going to pick a 5? I'm not going anywhere till a 5 shows up. Ah, there we go. Yes! Okay. Pie in the sky. I'm trying to think of what to do next. So certainly I want to test whether it's the correct digit or not. So thank you to Eve Anderson. I'm going to download this file with 1 million digits of pi, upload this file. And in the preload function, I'm going to load all of the data from that text file into a variable called pi. Now, what the load strings function does is it takes that text file and brings it into an array. So each chunk of digits that is on a separate line is a separate element of the array. So a very quick thing that I can do is just set pi equal to itself with the join function. And now I have in this variable pi 1 million digits of pi. Now I want to create a variable called pi counter. And the correct digit is the one at the pi counter index in the 1 million digits. I'm going to put the actual digit that I'm getting from that pi in a separate variable. This way I can say if the correct digit is equal to that digit, then console log a pi. Otherwise, if it's wrong, a train. And also, if it is correct, move on to the next digit. And maybe only add it to the string on the bottom if it was correct. So now I'm catching all of these. Oops. Oh, I misspelled correct. So we're seeing train emojis while I'm catching the incorrect digits. But if I could ever find a 1, there it is. Oh, it's not called pi counter? Oh, pi counter without the E, of course. Let's catch these. Okay, train emojis. Now let's look for a 1. Okay, good. And I got a pi. I need more pies. Okay, we're getting somewhere. There are a lot of directions I could take this, but I would like to add a few more features before I go and just leave it to you to make the most amazing pie in the sky game that ever was created. I'm going to first increase the level of difficulty by, instead of drawing the digit, drawing a certain number of slices of pie. So the most slices there could be would be 9. And I'm going to use the arc function to draw each slice. Let me start by just drawing one slice. The arc function is just like the circle function. The difference is, instead of drawing a full circle, I'm drawing a portion of the circle from a starting angle to an ending angle. And because I'm using the arc function, I don't think I can get away with just the radius like with circle. I've got to consider the horizontal and vertical diameter of what would be a full ellipse. So I made another variable called d to store the diameter. Now I can give the start angle and the end angle. So let's try 0 and pi divided by 2. Let's make it a blueberry pie. And you can see there, each pie has a quarter of it blue. It's like falling Pac-Man. So now if the pie were divided into 9 slices, a full pie is 2 pi divided by 9. So that's 1 slice. So if I wanted to draw all 9 slices, I would need to start from I times a and go to I plus 1 times a, right? I want to go from 0 to the angle, or the angle to 2 times the angle, or 2 times the angle to 3 times the angle. So that's a full blueberry pie. Let's add a stroke. I forget, the arc function can actually draw the outline of the slice itself. And we can see that on the reference as I can draw it as open, chord, or pie. Of course, I want a pie. So these are my pies with 9 slices. Can you see that? Then I can change this 9 to this dot digit. So now, oh, this is really easy to play. I'm now filling in the correct number of slices based off of the digit. Let me change the look of the pie a little bit. And maybe it'll be more like a strawberry pie. I'm going to make the stroke weight a little thicker. And I think these pies need to be bigger. There we go. Oh my God, this is totally going to be impossible. What have I done? Where's 1 slice? I need 1 slice. Give me 1 slice. There's 1 slice. 1. Is that 4? No, that's 3. Ah, no, wait. Ah, that's 4. 4. Let's change this to no fill. It bugs me that the pies always have the slices in the same position. So I think I'm going to just add a little rotation, random rotation to them. Now, rotating a shape, in theory, you might think it's as simple as me saying, call the rotate function with the angle. But this is gonna set everything out of whack. Oh my God, craziness, kind of interesting, because everything is rotating around the point of origin in the canvas. So I have a full set of tutorials around how transformations work, but essentially, I need to make sure I move the origin of each rotation to the center of the pie itself. That's done with the translate function. Then the pie is drawn at 0, 0. So that each pie is self-contained with its own rotation, I can add the functions push before I translate rotate and pop after I translate and rotate. Okay, so we have falling pies, each with a number of slices in them, and we need to catch them in the order of the digits of pi. Let's make this game a bit more possible to play by actually displaying the correct digits that you're looking for. We'll call this pi show. In pi show, I'll use the substring function just to get out an initial set of digits. And then after I've caught a digit, I should slide it over. So every time I catch a digit, the digits shift. I wonder what this would look like if I didn't draw this circle at all. Oh yeah, I like the falling pies like this much better. That's more fun. This is kind of ridiculous showing so many digits. I'm sure those of you who are designers can think of a better way to display this, but for me, I'm just gonna move them over and just show a few. The live chat is making a very good point, which is that you don't see the 0 anymore. So I've got to put the circle back in there. But I could make the circle more subtle and have the slices have a thicker stroke weight. This I kind of like. You know, I should just only display the one you're looking for and the next one. So let's make this 2 digits. And when I draw them, this is a little silly, but let me draw it twice. When the second time I draw it, just draw the first character, so the first one is green. And so I know what I'm looking for and what's coming up next. So now I need to get a 1. That's a 1. I need to get a 4. I've been at this for a while. I need to wrap this up. Let's make the game very simple. If you get the correct digit, you keep going. If you get the wrong digit, the game is over. A Boolean variable, game over, is false. Instead of console logging a train if it's the wrong digit, game over is true. And I can say now at the beginning of draw, if game over, background red, fill 255, text align, center, center, text game over, go and enjoy some pie, and then return. Get out of draw, don't do the rest of it. So now as soon as I catch the wrong digit, I need to say where the text should be. Game over, and enjoy some pie. Breaking news. I'm being told that silver would be a nice color for the plate. Let's try that. There we go. So now we see that there's a plate. Design aside, I think we have a somewhat finished version of this game that I could actually play. First, let me give myself quite a bit of a wider space to play the game. And here we go. Ready, everyone? I'm about to play Pie in the Sky. Okay, I need a 1. I need a 1. It's going to be really sad if I don't even get past 1. Oh, there's a 1. Okay, 1. Now I need a 4. I probably should lose if a 4 goes by and I don't catch it. But, you know, who's the real loser here? I think it's definitely me. Shoot. I only got 1 digit. That was so sad. There it is. Okay, 1. Okay, I need a 4. 4, it's like hard to find the 4. There's a 4. 4. I need a 1 again? 3.141. Yes, it's so confusing. A 1, then a 5. 1. Okay, now I need a 5. Is that a 5? No! Shoot. Hey, come on. I got to at least include in this video a version of it where I make it past the 3rd digit. I can even remember past the 3rd digit. One more time. There's a 1. Can you get it? 1. No. Now I need a 5. I haven't been able to get past the 4. That's a 3, that's a 5. 5, now I need a 9. Okay, there's a 9. 9, no, I missed it? Let me find a 9, there's a 9. Oh, I'm gonna get this one, 9. Okay, now I need a 2. There's a 2, there's a 2. 2, 6, oh God, 6? That's a 6, oh, I missed it. I just like have to, it's so much work to avoid everything. This is a 6, right? 6, yes. That's a 5. 5, what do I need now? 3? I need a 3, that's a 3. 3, I need a 5 again? Oh my God, that's a 5, that's a 5. No, I missed it. Oh, that's a 5, that's a 5. 5, 8, 8, 8, 8 is that one. Ah, 9, I need a 9, there's a 9. No, ah, here's a 9, here's a 9. 9, okay. 7, what's 7? 7 is missing 2 slices, so that's a 7. 9, 3, I need a 3. 3, well, once you get the hang of it, oh no, I'm in deep trouble here. An 8. An 8 is 1 missing. That's an 8. So I get it? 4, that's a 4. 6. Ah, okay, ta-da! I did pretty well there. Can you beat my high score? Well, that's all I've got for you today. So happy Pi Day to you. I hope you enjoyed this coding challenge. I hope that you are inspired to make your own Pi-themed game, whatever that might be. I will make a version of this with Coding Train character illustrations that you can play and you can base your code on. Please share it with me to celebrate the day. There's a link in the video's description to the Coding Train website where you can submit your version of your own Pi game. Have a wonderful Pi Day, everybody!